Hello again and welcome. Thank you for joining us on Space Nuts. It's all about astronomy and space science, and sometimes it's about animals because they interrupt us from time to time. My name is Andrew Dunkley, your host, and today we've got a lot to talk about. A shameless self-promotion by Fred Watson about a particular new book. We're also going to talk about a new exoplanet. Now, we've found thousands of them so far, but interestingly, they've all been in our galaxy until now, perhaps. We'll talk about that. There was a mystery signal identified late last year. We think we know what it is, and it's not very exciting at all. Could be a broken microwave. Now, we'll have to tell that story now that I've mentioned that. And we're going to tackle 3 audio questions today, one on dark matter. Shocker. Another that I found most interesting, though, about niche locations where we could live if we ever had to leave Earth, or maybe if we want to expand, when Earth's just too small for how many people there are. And asteroid mining. That's all coming up on this edition of Space Nuts. And joining me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Good day, Andrew. How's it going? How's it going over there in Dubai?
It's going very, very well. Yes, enjoying freedom after all that lockdown stuff. And funny thing is, Judy and I went out on Sunday to do a bit of shopping on the other side of town where we haven't been for over 2 months. And we drove through an intersection that's been rebuilt and we didn't recognise it. And a petrol station has turned up that wasn't there before. So it's just really weird. And it's a couple of kilometres away, so it's not far down the road, but we just haven't been able to go anywhere near that. So it's been bizarre. I'm sure other people have experienced similar things. Now, Fred, we've got a lot to tackle today, but first of all, Space Warp. Space Warp, the book.
The book, Space Warp, the book.
Has that been officially launched now?
Not until next Monday, the 1st of November. That's when it comes out. It's got words on the back as well, including some very nice...
That costs extra.
Well, yeah, there's some very nice endorsements by some famous people, including the founding head of the Australian Space Agency, Megan Clark, and the Astronomer Royal for Scotland, Catherine Haymans, Dr. Carl, who you all know of, has written something nice, as has Alan Duffy and Libby Gleeson, who's a famous children's author. And this is a book for young people. That's why Libby has played that part.
Nice. Yeah. Note well, I was not asked.
Well, look, it's not me who does this. It's the publisher. They just pick the people. Okay. No, the publisher.
I wouldn't have said anything nice anyway, Fred.
I'm going to throw in another bit of self-promotion, Andrew, because alongside the book, there is the calendar, the 2022 Space Warp calendar, which
look at that.
Is, because the book's full of my cartoons, and there's lots of them in there.
You do your own
calendar, things like that.
Wow.
So, yes, that will, we hope, be available, both of them will be available via the Space Nuts website, Space Nuts podcast website.
Yes,
right?
yes, we've got a Space Nuts shop on our website, so we'll make sure that they're available there. So we'll let you know when they'll pop up, but it won't be long. But yeah, congratulations, Fred. I know you've been working hard on that, and it's very exciting news indeed. So can't wait to get my free copy.
No, you will. No, you'll get one, don't worry. You're on the list.
Yes, right at the bottom. All right. Yes, it's called Space Warp, by the way. It's a book about astronomy for young people. So, if you've got a budding young astronomer or space traveller in the family, there you go. Could be for them. Now, speaking of space travellers, we are, well, it's not so much about space travel. It's about observing beyond our locality in space. And that is a new exoplanet. Now, to date, we've found several thousand of them, and we continue to find them through the various techniques. But this one is different. This one may well be the first exoplanet discovered beyond our galaxy. Now, most people will probably say, well, yeah, that's no surprise. We should expect that. But still, pretty exciting to be the first one, if that's the case.
It is. there's a lot of media hype around this story, Andrew.
I know.
And it probably isn't the first one. There've been other candidates. The thing is, detecting a planet of a star in a different galaxy is a monumental achievement. It is such a big thing. It's hard enough to find them in our own galaxy, and all the ones that have been found are probably within, I don't know, probably within a few hundred thousand. Sorry, not even a few hundred thousand, a few tens of thousands of light years away. There's some evidence of exoplanets in the region of the galactic center, which is about 27,000 light years from our solar system. So that's the sort of range that we're talking about. But when you get to galaxies, you're talking about things that are millions of light years away, and often billions. And let me sort of set the record straight a little bit, because there have been candidates for extrasolar planets, in extragalactic systems. In other words, galaxies beyond our own. There are already about 3 or 4 candidates for these, and of course the difficulty is how do you prove it? And so I would preface this story with that note of caution that it may well not be the first, but it's certainly a notable achievement, and it's a really interesting observation as well. It's of an object. So let me tell you that this has been detected by the Chandra X-ray telescope. It's not visible light telescopes that have picked this up, but a telescope that observes at X-ray wavelengths. And Chandra is a NASA observatory, the sort of X-ray equivalent of the Hubble Space Telescope. What they've done, the astronomers, they've been looking. Actually, I think they've looked at several relatively nearby galaxies, including M51, Messier 51, which is often called the Whirlpool galaxy because that's what it looks like. And that's about 28 million light years away, meaning it's 10 times further away than the Andromeda galaxy, which is our nearest big galaxy. So it's quite a way off. But using the X-ray observatory, what they've been doing is looking at the X-ray signal from basically binary systems which contain highly condensed objects, by which I mean a neutron star or a black hole or both. It's usually the kind of scenario that we've got, and this is the way that most X-ray objects in the sky shine in X-rays. You've got something like a neutron star or a black hole with a companion normal star going around it. And the gravitational pull of the neutron star is pulling stuff off the companion, and it's basically that material whizzes around the neutron star or black hole. It gets highly heated and glows in X-rays. But now here's the trick: that region where the X-rays are produced is very small. And if you had a planet that was in orbit around one or both of these objects, the star or the neutron star or the black hole, whatever it is, if you have a planet in orbit around it, that planet could block off most of the X radiation coming from that small source of X-rays because of the superheated gas.
Okay.
And it makes available the transit method, the standard transit method, which is what we use in our galaxy, where a star passes in front, I beg your pardon, a planet passes in front of its parent star. We see a dip in the light, which has a very characteristic shape in its light profile. And that demonstrates that there is a planet in orbit around the star. And usually what you have to do is watch this for several transits. I think 3 is the minimum before you can guarantee that you've found a planet. This is slightly different because the X-ray source, unlike the parent star of a planet in our galaxy, which is much bigger than the star, so all you get is a dimming of that star's light. I beg your pardon. It's much bigger than the planet. I'm sorry. Get the words right. The star is much bigger than the planet in our galaxy. And so as the planet crosses in front of the star, it's like the starlight merely dims. But with this situation, the X-ray source is smaller than the planet. And so when the planet passes in front of it, it basically switches off the X-rays.
Wow.
And then they come back on again.
Yeah.
So there is a known X-ray source in M51, the Whirlpool galaxy. Its name is M51 ULS1. And that is either a black hole or a neutron star with a companion star, which is about 20 solar masses. And that basically is what causes the bright X-ray emission. So all that's been modeled from the X-ray emission. But now what you've got to do is monitor this and look for a planet or something blocking it off. And that's what they found. It's basically a dimming of the light. It lasted about 3 hours when the X-ray emission fell to 0. And so that's what they are interpreting as a planet around M51 ULS1. And they guess it's about the size of Saturn and think that it would orbit the black hole or the neutron star about twice as far away from the neutron star as Saturn is from the sun.
Right.
The really depressing bit, Andrew, is that based on those calculations, the next time it's going to block out the light of the X-ray source is in 70 years. So we've got a long wait before you can actually guarantee that this is definitely a planet.
That's frustrating.
Yeah, very frustrating. It's been, other people have suggested maybe it's actually a cloud of gas and dust that's passing in front of the X-ray source. They say that the characteristics of that dimming of the light, or the X-rays from M51 ULS1, is more consistent with a solid object like a planet. There's a very nice comment by one of the authors who's at Princeton University in New Jersey. We know we are making an exciting and bold claim, so we expect that other astronomers will look at it very carefully. This is Julia Bernson. She says, we think we have a strong argument, and this process is how science works.
Yeah. It must be frustrating when you find something and then realise you're going to have to wait 140 years to get an absolute confirmation.
Yeah, that's right.
I dare say we'll find other candidates before that happens. But
I think we might.
Why is it so difficult to confirm an exoplanet in another galaxy? Is it because when we look out, everything's just conglomerated into one mass?
Yeah, well, that's partly
telling one from another is the issue.
Yeah, so that's why you've got to. So if you were just looking at straightforward stars, you wouldn't have a chance, because at the distance of M51, the bright ones will show up individually. But most stars just melt into a haze, a bit like the way we see the Milky Way, that haze of starlight. But X-ray sources are different. First of all, they're relatively rare within a galaxy, so you can pick them out easily because they are so bright in X-rays compared with the background from the galaxy itself. There's probably other aspects. I'm not that cluey about the details of X-ray astronomy, but I think it's likely that you would be looking for a different region of the X-ray spectrum for the kind of observations that we're talking about here, from the what we call the extragalactic X-ray background, things of that sort. So so it's a difficult task, and that's why you need something really extraordinary like an X-ray source and a tiny X-ray source, which is what this is, in order to have some evidence of a planet there. Yeah,
well, hopefully, but yes, as we've mentioned, it'll be a while before we can
for this one, that's
properly
right.
confirm it. Yeah. But yes, look, logic says that there are probably squillions of exoplanets in other galaxies, just like there are in our galaxy. We've got planets around our star. We've found planets around many other stars in our galaxy. It stands to reason that the pattern repeats.
Yes,
so
that's right.
One day soon, I'm sure, we will confirm an exoplanet in another galaxy, and everyone will go, yeah, we thought that'd be there. It'll be exciting, but it will also be expected. That's how I anticipate it going. So, and yeah, as you said, we've probably already discovered them. We just can't absolutely confirm it yet.
That's right. There are other candidates that come from things like gravitational lensing or gravitational microlensing and things of that sort.
Yes. All right. We wait with interest.
We do.
Can't afford the interest, but we're going to do it anyway. You're listening to Space Nuts, and you're watching us on YouTube if you choose to, where you can see the cover of Fred's new book, which he just showed us if you want to take a look at it, with Andrew Dunkley, of course. There he goes again, and Professor Fred Watson. Now, Fred, before we move to our next topic, I got a lovely email this week, and basically asking for help. And I thought, well, yeah, why not? Let's give them help. Hi, guys. I'm an avid listener of your podcast and have just started working in marketing for the University of South Australia Innovation and Collaboration Centre based in Adelaide. And that's where they run the Venture Catalyst Space Program, which he tells me is a 6-month startup incubator for local and international companies in the space sector, with the support of the South Australian Government Space Innovation Fund. And right now, this is from Daniel, he tells me that they're accepting applicants for the 2022 program. Now, that closes on November the 28th. And he was hoping we could mention it to our listeners and maybe get that message out to people who could take advantage of this wonderful opportunity. So there you have it. If you're interested in this 6-month program for companies in the space sector, get in touch with the University of South Australia's Innovation and Collaboration Centre based in Adelaide and see what you can do for their 2022 program. I'm sure Daniel will be excited to hear from you. And you never know where it might lead. So good work, Daniel. Thanks for getting in touch. More than happy to give you a little plug on that program and wish you all the very best. And please stay in touch. Let us know how it goes. Sounds fantastic. Adelaide's becoming quite a centre for space in Australia, isn't it, Fred?
Very much so, yes, with the Space Agency having its headquarters there. And South Australia, of course, has a long history of space activities going back to the Woomera days. And they've picked up all that again with this new wave of investment in space projects. And
I still love how we have sort of taken in the space program in Australia, and our very first rocket still lies on its side, rusting behind a chicken wire fence. I think that just underlines it for me in terms of Australians space. I think we'll improve on that. What's more, it was an American rocket and the kangaroo burnt off, so you can still see the American USA underneath. I think that's hilarious. Let's move on. Right. Now, last December, there were media reports of a mystery signal that we've been trying to unravel, and it came from a place that sort of got people scratching their heads. Well, now we think we know what it is. Over to you, Fred.
I might actually read what I wrote about it in this book, because I wrote about this. In December 2020, reports emerged that a signal had been detected at the Parkes Observatory in New South Wales in 2019, 3 years into the Breakthrough Listen project. That's a project to listen for extraterrestrial signals. Dubbed BLC-1 for Breakthrough Listen Candidate 1, the signal came from the direction of the nearest star, Proxima Centauri. Scientists are still working to identify its origin, but comment that it is 99.9% likely to be human-made interference of some kind.
Right.
I wrote this about 3 months ago, and now they've agreed that it is.
Yeah.
All the pundits that I spoke to said, look, it's got to be human interference. But there's a little bit more to the story. The signal had all kinds of similarities with what you might expect an extraterrestrial signal to look like. And in fact, people have been looking with the Parkes Radio Telescope at Proxima Centauri for a long time because it's a flare star. It flares out bursts of energy like our sun does, but because it's a red dwarf star, they're much more energetic. And so it's one that has been studied. We also know that Proxima Centauri has in orbit at least one Earth-sized exoplanet, and the suggestions here that that planet is, in the same way as the Earth experiences space weather from the solar flares, the space weather around Proxima Centauri B, that's the name of the planet, is pretty energetic. And I think most pundits think that would rule out the evolution and development of life. But yeah, it's the nearest neighbour. It's an object that's very easy to observe from our southern skies. And so the Breakthrough Listen team have essentially concentrated a little bit on Proxima Centauri, and sure enough, this signal came in. It reminds me a lot, Andrew, of the WOW signal. That nobody wrote WOW, but the reasons why the signal could be artificial have been listed in a very nice conversation piece by Danny Price, who's one of the authors. He's at Curtin University in Western Australia. So Danny lists the things. His conversation piece, if you want to look at it, is called "A Mysterious Signal Looked Like a Sign of Alien Technology, but it turned out to be radio interference." That's telling it like it is. What Danny says is that they only saw BLC-1 when they were looking towards Proxima Centauri and didn't see it when they looked elsewhere in what are called off-source observations. Whereas normally interference leaks into the telescope from everywhere. So that was one thing. Second point is that the signal it only covers one narrow band of frequencies. And, natural astrophysical sources are usually over a much wider range. Normally, clouds of cold hydrogen aren't, but normally you would get a much wider range. And the thing that really made it intriguing was that the signal drifted in frequency over a 5-hour period. And that's sort of what you would expect from a signal coming from a planet orbiting another star because of the Doppler effect. You get this Doppler shift because of the relative movement between the Earth and the star. Actually, the Earth's movement as well contributes to that. And it persisted for several hours. That's what they said. However, they have demonstrated, and I think it's a summer project that was being done by a PhD student, Sophia Sheikh, I think is the name, the way her name is pronounced, a PhD student at Penn State in the USA, who ran lots and lots of tests, which have basically what has thrown out the techno signature idea, that which is of course a signature coming from a technologically advanced society. She has done this by going across the Parkes receiver's complete frequency range and actually found lookalike signals that are similar to BLC-1, which do appear in off-source observations. And so it suggests that it's actually some sort of peculiar radio interference. And what they're saying, and this is me quoting directly from Danny's article, we don't know exactly where BLC-1 was coming from or why it wasn't detected in off-source observations like the lookalike signals. Our best guess is that BLC-1 and the lookalikes are generated by a process called intermodulation, where two frequencies mix together to create new interference. If you've listened to blues or rock guitar, you're probably familiar with intermodulation. I have to say, when I'm playing blues guitar, I don't intermodulate, Andrew, as you'd expect, mainly because I don't use an amp. I'm purely acoustic. when a guitar amp is deliberately overdriven, i.e. when you turn it up to 11, intermodulation adds a pleasant-sounding distortion to the clean guitar signal. So BLC1 is perhaps just an unpleasant distortion from a device with an overdriven radio frequency amplifier.
Well, that's disappointing.
It is.
But not unexpected. It reminds me of a story, and I can't remember the details, but some years ago there was some kind of discovery made, and then they eventually figured out it was like a broken microwave oven.
Yes.
Do you remember that?
No, yeah, it wasn't broken. And this is Parkes as well.
Right.
Yeah, so this was in the early history of the detection of fast radio bursts, which are signals that last a few milliseconds, which are now generally thought to be coming from flares on neutron stars. I think that's the consensus these days. But in the early days, nobody had a clue what they were. And they found a whole succession of these signals, exactly like the what we might call the classical fast radio bursts, from the Parkes radio dish. They had this same intensity profile. They had a phenomenon called dispersion, which is actually something that happens to radio signals as they pass through space. The low frequency signals, let me get it the right way around. I always get this the wrong way around. I think the lower frequencies come last. They do, they're slower. So that's dispersion as they pass through space. And these signals at Parkes mimic that. They had the dispersion. So everybody thought they were natural, except for one thing, cosmic, coming from space. Excuse me, except for one thing, which is that they always turned up at lunchtime. And anything that comes up on a period of 24 hours must be something to do with the Earth. So they started then looking at nuclear tests and jet aircraft interference. And it took a long, long time. And I've talked to one of the guys who actually discovered what it was, John Sarkisian, a great friend and colleague at the Parkes dish. What it turned out to be was people, I should say, they ran tests on all the microwave ovens in the district, and nothing that turned them on and off and everything, not got anything that resembled this thing. And I should say they gave it a name. They called them peritons, which is a fictitious animal invented by an Argentinian a fiction writer. So the peritons it turned out to be caused when somebody's cooking a meal, and they think that the cooking's done enough, but the microwave's still running, and they press the door open button, and it cuts the microwave, but it lets the radio radiation, as it decays, expand into space. And they did several tests, and that's what it was. I think it was John Reynolds as the person. So
that's what would happen, where it's finished cooking and it's giving you the 5 warning beeps, or however many it is, and you open the door before the beeps stop.
It's more,
the radiation's escaping.
It's more that you say, you're looking through the window and you've got 5 minutes on the timer, but after 3.5 minutes it's cooked, and you press the door open button then. So the magnetron is still generating the microwaves. The door opens, the microwaves escape into space, and they've got this frequency drop, exactly as you'd expect. So
that's what it was.
Yeah.
That's amazing. And it's not advised either, is it? You shouldn't do that.
You shouldn't. It's very naughty. That's right. And so it's not forbidden.
Which is why it gives you the warning beeps. Don't open the door till the beeps stop. That's what that's all about. Yeah, it's not to tell you your food's cooked.
That's right. Yes. Leave it up until the beeps stop.
Another important safety tip from Space Nuts.
Indeed. Yes. Look after
all
your
right.
microwave.
So the mystery signal, not such a mystery. Not a microwave oven thing, but certainly some kind of interference.
That's right.
Yes. All right. This is Space Nuts. You're with Andrew Dunkley and Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.